Hey, it's Peter Vestnes, here to talk to you about TEEs and identity. Also, I've gotten requests for me to do the guns. Happy to do them. Glad to see you guys. Glad to be back. So, trusted execution environment, identity. This is just a kind of an open area of research as far as I know, and it has to do with this question of, okay, we've gone ahead and built out an infrastructure where if a chip does math, if a chip does some secure execution for me and provides a signature back, it says, yeah, I did this secure execution, that would be great. As a side note, why would that be great? Well, we go through a lot of work in blockchain land to make sure that parties that we don't trust on the other side are using the same data that we are using. Why would that matter? Well, like in Bitcoin, it's kind of obvious. I want everyone in the world to agree with me about what my Bitcoin balances are. Of course, they're too low, so maybe I wouldn't. I wish they thought I had more, but for fairness, we all have to agree at all times about what people have, right? And so there's all these rules in the creation of these blockchains that very narrowly enforce the kinds of math and operations we can do, and then have all these checks to make sure that everybody's doing the same thing at the same time. So trusted execution environment is like a way to really expand how much computation could safely be done. And when when Ethereum launched, Vitalik and Gav's bright idea was that a really brilliant one is hey, we could actually kind of loosen up. We could do a lot more computation than Bitcoin thought was safe if we attach costing to the operations that we're doing, and make sure that we build this thing that's deterministic in its output. And that was a very, very, very brilliant idea because it added all this flexibility to how things are processed on these blockchains. But one of the things it relies on is that every mining node has to go do all the computations. So Ethereum's the least efficient computer in the world. If there's 50,000 miners, they're all processing this stuff 50,000 times for the one time I want to execute it. And that's terrible, truly terrible. And was a trade-off that got this big innovation out there. So it would be awesome if could we get down to 3 or 4 times instead of 50,000? And that's sort of the impetus for this idea of well, if we have these trusted execution environments that are considered cryptographically secure places to do math and to therefore do program execution, maybe we could get a lot of that speed and scale we need in blockchain land, as I've been discussing over the last few weeks, and be more energy efficient, be more ecologically friendly. And so there's this strong lure to using these TEEs. Now, they're in most modern chips. Intel has SGX, which was originally pushed as a server platform technology. ARM has it in at least some variants of ARMv8 will have a TEE. I forget what it's called right now. So major players have got something that you could tap for this right now. But here's how it works. You call up a chip and you're hey, tell me who you are. And it sends you a public key, sends you a signature back. You can check on a public key. Yep, talking to the right chip. Do this math for me. Send me, and then send me a certificate it was processed through a program that I trust. Okay, does the math, comes back, output and certificate. These inputs, this program variant that we both trust. My signature, get them both back. So that's cool. There's pretty much nothing you can do in hardware that you can't do in software. So what this fundamental security of these certificates relies on is public key cryptography. And what that means is you need to have a list of which chips have which keys. And Intel uses that. The way Intel implements this is you got to go talk to their servers and be is this chip okay? Yes, it is. So for blockchainers, this is not okay. We can't trust Intel's name resolution and chip name resolution service. to go do this, and also it's slow and it doesn't work at scale. So we're like, on the one hand, you have this thing like, yeah, I've got a mechanism now like to like get a proof like that stuff was operated on properly. If you've listened to my video on MAST, Merkle's abstract syntax trees, you know that like there's a lot of interesting stuff that could be done even in software. But we still have this problem over here is like identity, like who's who? Am I actually talking to somebody safe? And I think one of the undecided things in this part of the innovation space in blockchain land is like, what do we do about that question? This is a very, very, very hard question. And I'm cautious about like, it's in the class of like questions that I call like Nobel Prize category questions. Like if you can actually know who you're talking to perfectly without a central repository of information, probably won a Nobel Prize. So those of you smart enough to fix this problem should go do that and benefit the rest of the world. In the meantime, those of us who aren't smart enough to solve the big problem need to kind of like decompose it, kind of work around it, figure a way that we can get most of what we need. And the simplest way to do that with TEE is just like, kind of an ensemble approach where you're like, I'd like 10 of you to do this computation, come back to me, and if the output's good from all 10 of you, I'm pretty comfortable. And you might layer this with like reputation systems or being able to blackball. If you can get a signed thing back from someone that's provably false, then you could start blackballing a network out. Lots of problems with this approach. Like you have to think about how attackers might try and segment your network and get you over talking only to bad guys, or get themselves in a world where good guys can't find out they're doing bad things. So this is sort of like getting down to the messy nitty-gritty of like crypto protocol specification rather than just some like perfect technology up here. It'd be great if there was such a thing. I'm not aware of it. And in fact, I think anecdotally, crypto designers, you can see, are like very worried and skeptical about getting this wrong. So like blockchains like Grin, which are really cool, kind of more modern Mimblewimble based blockchains are like even walking back from Bitcoin's computations, and they're like, we'll only do computation you can do on an elliptic curve, full stop. So like they're like, yeah, we don't want a stack based language in here. Like it's just too much. It's too much. So we have kind of this like both like simplification, there's a tribe that's like simplifying down into like very, very provably safe. And then you've got kind of the like move fast and break things, or those guys are not moving so fast anymore, but they kind of want to keep innovating in a like a more rough and tumble way. And I think that's probably where that crowd is probably where we'll see these innovations come from. And I think probably Ensemble plus provable fraud technologies is like good enough for a first take and would provide a lot of benefit, a lot of benefit. And so I think we would, if we layer in these concepts from like Blockstream, where like, your chain is like could be more of a settlement layer, like your place of last resort to deal with really, really bad things that happened. But what they would call like side chains or like your kind of like your other communication channels have some built-in stuff, and then recourse when you need it, and a recourse is slow and expensive. I think we'll sort of see these concepts layered in there, where that like in a local communications area, we'll get almost all the benefits of this like high speed, near wire speed computation, trusted computation shared. And then when there's like a problem, or we think there's a problem, we can pay to kind of figure out exactly what happened. So that's what I expect, and I think I will be talking more about this because it goes into what I want to talk about for my V5 blockchain design. And so we'll come at you with more of this later. Thanks so much.